So this video is on solving linear systems using algebra. Basically, we're finding where two lines intersect without actually graphing the lines. So I've got 3 examples we're going to run through, and then we're going to look at 2 special cases at the end here. The instructions are in this box of what to do, and we'll run through that and solve each one as we go through it. So for this first example, we've got 2 linear equations. One is 12x minus 9y equals 36, and the other one is y equals 4. And so step 1 says solve one equation for x or y, and we're done with that. We have y equals 4. And then it says take the solved equation, y equals 4, and plug it into the other equation. So what I mean by that is we're going to take 12x minus 9y, and we're going to put in for y what we found it is, and since they told us that y is 4, we're just going to put a 4 in for y into the original, in the first equation. So then we evaluate that. 9 times 4 is 36. I'm going to add 36 to both sides. So we did step 2. Now there's only one variable we're going to solve. We're on step 3. We've got 12x equals 72. Divide by 12. And we get x equals 6. So we got step 3, we solve for that variable. Now step 4 says take your answer and plug it back into either equation to solve for the other variable. Well, this is also kind of done for us because they tell us that y is 4, so we don't really have to solve. If we plug 6 into the original equation and solve it for y, we'll get 4. But take the easier route, and they already told us y is 4, so we're done. So our final answer is x equals 6 and y equals 4. Most of the time what you'll see is the answer written as an ordered pair, so 6, 4. If you graph these, this is where on the graph the 2 lines are going to intersect. All right, so there's the first example. Try to keep it relatively simple. We're going to move our way up in complication here. So with example 2, we have 3x plus 2y equals 1, and then y equals 2x plus 4. Step 1, solve one equation for x or y. Well, we already have that done. We've got y equals for the second equation, so that's good. So far, we haven't had to do step 1 yet. Trust me, it's coming. Step 2, take the solved equation and plug it into the other equation. So we have y equals 2x plus 4, so what I'm going to do is write the other equation, 3x plus 2y equals 1. And since y equals 2x plus 4, I'm going to take that and drop it into that set of parentheses. So I'll just rewrite it, 3x plus 2 times 2x plus 4 equals 1. And then we're just going to solve it. So we're going to distribute the 2 in. We've got 3x plus 4x plus 8 equals 1. Combine like terms, 7x plus 8 equals 1. Subtract 8 from both sides. We've got 7x equals negative 7. And then divide by 7, and we get x equals negative 1. All right, so we plugged it in. We solved for x. Now all we have to do is take that x and plug it in to one of those two. So it probably would be easiest to put it in for that x right there. I'll do that over here. We've got y equals 2 times x plus 4. And since x is negative 1, we plug that in for x. So we've got negative 2 plus 4, and negative 2 plus 4 is 2. So our final answer here is x is negative 1 and y is 2. So that means on the graph at negative 1, 2, that's where those 2 lines are going to intersect or cross. Okay, so let's do one more example. We'll look at a couple special cases. So here's another example. We've got 4x plus 2y equals 24, and 2y plus x equals 6. So step 1, we have to solve one equation for x or y. And it looks like the second equation might be relatively easy to solve for x, so I'm going to subtract 2y on both sides. And I get x equals 6 minus 2y. So, step 1 done. Boom. Take that solved equation, and we are going to plug it into the other equation. So we have 4 times x, and I solved it for x, so I'm going to replace the x with parentheses, plus 2y equals 24. And since x is 6 minus 2y, I'm going to put that in for x. So, step 2 done. Take that solved equation and plug it into the other equation. So now we're going to distribute. We've got 24 minus 8y plus 2y equals 24. And then we can combine like terms here. We get 24 minus 6y equals 24. Subtract 24 from both sides. Negative 6y equals 0. Divide by negative 6, and we get y equals 0. All right. So then, since we solved y is 0, I can take and plug that in to this equation, and I have x equals 6 minus 2 times 0, because y is 0. So x equals 6 minus 0, which is 6. So our intersection point is going to be 6, 0. That's where those two lines will cross. And if you plug this into a graphing calculator, they should intersect at 6, 0. That's a great way to check your algebra every time. Okay, so let's take a peek at these special cases. We've got example 4 and example 5 here. Same procedure. I'm not going to check off step 1, 2, 3, 4. Hopefully we have it down by now. So what I'm going to do is I'm going to start by solving the top one for y. So this would be y equals 3x plus 2. I just added 2 to both sides. And then I'm going to put that in for y into the other equation. So 3 times y minus 9x equals 6. And then I'm going to put this stuff in there, so 3x plus 2. All right, so distribute, we've got 9x plus 6 minus 9x equals 6. Well, if we combine like terms here, 9x and minus 9x, we get the x's cancel out, and we're left with 6 equals 6. So this is kind of weird. We tried solving for x and we got rid of the x. So what does this mean? Well, in this situation, whenever you get something like this, where it's like 6 equals 6, or 5 equals 5, or a billion equals a billion, whatever, when you solve it, if it's something equals itself, then this means there are an infinite number of solutions. In other words, it means this is the same line for both equations. And if you're wondering how can that be, basically each equation would graph, if this is one of the equations, the black one, then the green one would be the same one. It'd be right on top of it. So there's an infinite number of solutions. Everywhere that line exists is a solution to this. They're basically the same line. Okay, so that's the special case number 1. For special case number 2, we've got this. So I'm going to solve one of these for y or x. And I think I'm going to solve the second one for y. So if I do that, I get y equals 5x plus 3. I just added 5x to both sides. So then I'm going to plug that in for y. Y is 5x plus 3. I'm going to plug it into the other equation. So we've got 2 times y equals 10x minus 4. And what I plug in there is 5x plus 3. This, and then we distribute, we get 10x plus 6 equals 10x minus 4. I'm going to subtract 10x from both sides. And I get 6 equals negative 4. And so that, I hope you realize, is not true. So what's happening here? Well, we can't, 6 is not equal to negative 4. We know that's not true. 6 is 6 and negative 4 is negative 4. So what this means is there's no solution. That means that the lines never intersect. Which means they are parallel. So this would be special case number 2. When you solve it, everything cancels out and you get like some number equals a different number. That just means that on the graph, when you graph these two lines, one might be up here and one might be down there, but they are parallel and they'll never cross. All right, so that is it for solving by substitution.